Hello everyone, this is the continuation of the addition and subtraction of rational algebraic expressions. In this case, we will be dealing with rational algebraic expressions whose denominators are not the same. For the prerequisite lesson, you should know how to identify the least common denominator or the LCD of dissimilar fractions. Let us review how to add and subtract dissimilar fractions. 1/4 plus 1 over 6. As you can see, the denominators are not the same. Therefore, we cannot add right away these fractions. We need to make the denominators first equivalent. To do that, let us express into prime factorization the two denominators. 4 is the same as 2 times 2, while 6 is the same as 3 times 2. And to make this equal, we need to add a factor of 3 for our first denominator, while a factor of 2 for our second denominator, so that both of them becomes 3 times 2 times 2. To do that, we need to multiply our first fraction by 3 over 3. Remember that 3 over 3 is just equivalent to 1, and any number multiplied by 1 is the number itself, as if we did nothing to our fraction. For our second fraction, we need to multiply it by 2 over 2. And again, that is just the same as 1. Multiplying 1/4 and 3 over 3, the result is 3 over 12. 1 times 3, we have 3. 4 times 3, we have 12. 3 over 12, when simplified, becomes 1/4, meaning to say we just change its appearance, but its values is still the same. 1 over 6 times 2 over 2 for our second fraction. 1 times 2, we have 2. 6 times 2, we have 12. And 2 over 12 is just the same as 1 over 6. So now the denominators are the same. We can proceed now in adding these two fractions. Adding the numerators 3 plus 2, we have 5. Copying the denominator, answer now is 5 over 12. If in case the operation is minus, then we should have 3 over 12 minus 2 over 12 instead. Subtracting the numerators, 3 minus 2, we have 1. Copying the denominator, the answer is 1 over 12. Let us proceed in adding the similar rational algebraic expressions. 3 over 5a squared b plus 7 over 10ab squared. And as you can see, the denominators are not the same. So we need to find a way first on how to make these denominators equal. We can do that by expressing them in prime factored form. The first denominator is equivalent to 5 times a times a times b, while the second denominator has prime factors 5 times 2 times a times b times b. Thus, we need to include a factor of 2 and a factor of b for our first denominator, while a factor of a for our second denominator, so that both of them becomes 5 times 2 times a times a times b, or 10a squared b squared. The first fraction now will be multiplied by 2b over 2b, while the second fraction will be multiplied by a over a. The results are 3 times 2b, we have 6b, 5a squared b times 2b, the answer is 10a squared b squared, plus 7 times a, answer is 7a, 10ab squared times a is 10a squared b squared. Now the denominators are the same. We can now proceed in adding the numerators. Since we cannot add these two dissimilar terms, we will just express them as 6b plus 7a all over the denominator 10a squared b squared. For our second example, let's subtract m over m squared minus 6m plus 9 minus 3 over m squared minus 9. The denominators again are not the same. Let us express the denominators in factored form. m over the square of m minus 3 because the first denominator is an example of a perfect square trinomial, while our second denominator, m squared minus 9, is an example of a difference of two squares which can be expressed as the quantity m plus 3 times the quantity of m minus 3. And as you can see, we need to include a factor of m plus 3 for our first denominator, while for the second denominator, we need to add a factor of m minus 3, so that both of them becomes the quantity of m plus 3 times the quantity of m minus 3 times the quantity of m minus 3. To do that, let's multiply m plus 3 over m plus 3 for our first fraction, while m minus 3 all over m minus 3 for our second fraction. The results are m squared plus 3m, applying distributive property, m times m we have m squared, m times 3 we have 3m, retaining the operation plus, all over our LCD, the square of m minus 3 multiplied by the quantity m plus 3, minus, applying again distributive property of multiplication, 3 times m we have 3m, copying minus, 3 times 3 we have 9, all over the same denominator, the square of m minus 3 times the quantity m plus 3. Since the denominators are now the same, we can perform subtraction to our numerators. Copying m squared, subtracting 3m and another 3m, we have 0. The negative of a negative 9 is positive, so let's put plus 9 all over the denominator, the square of m minus 3 times the quantity m plus 3. Thank you for watching. If you like this video, click on the thumbs up below. You may also check our previous video, and I would really appreciate if you will subscribe to my channel.